right, part 3 of the lesson. This is where we're just going to practice and then do a little bit of spiral in order to review some of the general concepts. Let's go ahead and finish this up. All right. Rewrite each radical by extracting all possible roots, and then rewrite using rational exponents. Bada bing, bada boom. So immediately I see that this is a square root because there's no index listed. You can see in 23 that when the index is listed, you go with that, but otherwise we assume it's going to be 2. So since this is square root, what we're going to do is we're going to represent this to be x to the 3 halves. That 2 came from the invisible index. I go ahead and divide this. So I ask myself, how many times does 2 go into 3? Well, if I do division, 2 goes into 3 one time. I have 1 and 1/2 left. So this is going to be x to the 1 and 1/2. To finish this, I'm going to split it up. It's going to be x to the 1/2 times x to the 1/2. And then this, I'm going to drop the x and turn that into a radical. It is going to be to the first power, which is going to be x times the square root of x. Remember, with an exponent of 1 or an index of 2, you do not need to write it out. This next one, a little more complicated. Same principle. Take the square root of 16. I'm going to take the square root of x to the 4th. And I'm going to take the square root of y to the 3rd. The square root of 16 is a whole number. This is just going to be 4 times, when I rewrite x to the 4th, it's going to be 4 over 2 times y to the 3 halves. Both of these denominators came from the index being 2. Now, I'm going to go ahead and clean this up a little bit. It's going to be 4 again. 4 divided by 2 is going to be 2. And then it's going to be y and 1/2. 3 halves is 1 and 1/2. So I'm going to split this up. I'm going to go ahead and write this as 4x squared times y to the first times y to the 1/2. This is going to be 4x squared. I'm going to leave off the y. And I know that it's going to be the square root of y to the first. But I could actually clean it up further. I'm going to write it as 4x squared y. And since it's a square root, I'm just going to not write the square root symbol and not write the 1. And it looks a little cleaner. 23, same idea, except for I got to deal with the cube root. I'm going to have to deal with the cube root of 8. I'm going to have to deal with the cube root of x squared. I'm going to have to deal with the cube root of y to the 6. So the cube root of 8, what number of times itself 3 times is going to be 8? Is 2. Times, this is going to be x to the 2/3 times y to the 6/3. Well, when I'm going to keep on going, it's going to be 2 times, well, x to the 2/3 can't be split up, and then it's going to be times y squared. So when I'm rewriting it, I'm going to put my whole exponents over here times my radical, and then let's go ahead and change form. 2y squared, it's going to be the cube root of x squared. (24) and 25. This is simplified expression by applying the properties of exponents. When I see this, this is going to be a power to a power, means I'm going to multiply and distribute to each part. Likewise. So it's going to be x to the 4 halves times y to the 8 halves. This is going to reduce to be x squared times y to the 4th. Likewise on the right, I distribute my square, 4 squared, and then it's going to be multiplied by x to the 6th, and I'm going to multiply that by 2. This is going to lead me to have 16 times x to the 12th power. So this has been some rewriting some radicals. The rest of this lesson is just to review some previous concepts. All right, some of this review, list of transformations needed to change f of x into g of x. I look to see what's been changed, and I notice that there's a number being multiplied. I also know there's a number being added, and I know that there's a number in front. So what the heck is happening? Well, the transformations are as follows, is that I am going to be reflecting across the x-axis and stretch by 5. What else is happening is this 2 means that I am going to actually be shrinking horizontally by 2. To be precise, I should have actually stretched vertically by 2. And then finally, I have to shift up. Wow. Each piece of information communicates something different to me. I need to create a number 2, a new function, g of x, which is reflected over the x-axis. It is going to be translated to the right 4 and then translated 6 units up. So it's going to look like the following. It's going to be called g of x, is going to be reflected over the x-axis, so I need to put a negative in front. It is going to be translated to the right 4, so I have to remember to the right 4 is going to look like that, and then up 6 will look like so. And voila. For number 3, I have to find the inverse. Well, I know f of x is the same thing as y is equal to negative 5, x to the 3rd plus 7. I switch my x's and my y's. So for the inverse, it's going to be x is equal to negative 5, x to the 3rd plus 7. And my goal is to get, oops, that's supposed to be a y. My goal is to get y by itself. So I'm going to go in my inverse operation. So normally I go parentheses, exponents, multiply, divide, and then subtract. For the inverse, I'm going to go in the opposite order. So add and subtract first. I'll add 7. This is going to lead me to have x plus 7, which is equal to negative 5y to the 3rd. I'm going to then divide each side by negative 5. What this is going to lead me to have is that on the left side, I'm going to have x plus 7 divided by negative 5, and then it's going to be equal to y to the third. And I have to take the cube root of both sides and flip. Y is equal to the cube root of x plus 7 all over negative 5. Again, doing the same process as number 3. I'm going to switch my x's with my y's. So that's going to give me x is going to be equal to 2 with the index of 9 of y plus 7 minus 1. So we got to get y by itself. So first I got to get rid of some of this garbage. Got to add 1 to both sides. And then this is going to produce x plus 1, which is equal to 2 times 9 y plus 7, the ninth root. I'm going to divide both sides by 2. This is going to lead me to have x plus 1 over 2, which is equal to the ninth root of x plus 7. To get rid of the ninth root, I'm going to do the opposite. I'm going to raise both sides to the ninth power. So it's going to leave me with x plus 1 over 2 to the ninth power equals, this is supposed to be a y plus 7, y plus 7. To get y by itself, I'm going to minus 7 from both sides. So it's going to be y is going to be equal to x plus 1 divided by 2 to the ninth power minus 7. For number 5, I need to solve this equation using any method. Okay, I see it's equal to 0. Remember the 0 product property. It's equal to 0. Now I have to write it as a product, which means I'm going to have to factor it. So I'm going to have to factor out a term. So I need to think about basically what multiplies to be 3x to the 5th, negative 15x to the 4th, and negative 72x to the 3rd. Well, I know that 3 goes into 15 and 3 goes into 72. So 3 times 1 is 3. 3 times negative 5 is negative 15. And then I can use a quick calculator if I need to, but 3 times negative 24 will be 72. Now I figure out how many x's do they all have in common? Well, they all have 3. So I need 2 more, 1 more, and no more. This right here is the area model. This is representing the factoring process that should be going on mentally. I need to rewrite this factored. So this is going to be 3x to the 3rd power times x squared minus 5x minus 24. I still have to write it as a product. So I'm actually going to use the area model now for the newly found insides. I'm going to figure out x squared and negative 24. And the idea is I need to somehow get negative 5x. I know that negative 8 and positive 3 will result in negative 5x. I know x times x is going to be x squared. And what type of 3? Plus 3. So this is going to write into the equivalent statement 3x to the 3rd times x plus 3 times x minus 8. For the property, remember that this is equal to 0. Ask yourself, when does 3x to the 3rd make 0? Well, x has to be 0. Here, x has to be negative 3. And finally, x has to be 8. Those are the unique solutions. Number 6, find the solution to the two equations listed below. I see two variables, so I'm going to do some substitution. I'm going to go ahead and I know that since y is equal to negative 2x plus 5, I'm going to let y equal to negative 2x plus 5. So it's going to rewrite to be 2x plus 3 times negative 2x plus 5 equals negative 1. And I see that parenthesis, so I'm going to distribute. I'm going to distribute. It's going to be negative 6x plus 15 equals negative 1. I am going to go ahead and combine my 2x and negative 6x, 2x and negative 6x, 2x and negative 6x. It's going to be negative 4x plus 15 equals negative 1. What do I do now? Well, remember the same words. What is x? What am I going to do? I need to get x by itself. I'm going to minus 15. And then this is going to result in negative 4x equals negative 16. They're the same sign, so add them together. Negative 4x is equal to negative 16. This is going to lead me to divide by negative 4. And I'm going to have the following. X equals just 4. This is not enough to find the solution. Remember, I highlighted y is equal to negative 2 times x plus 5. X is 4. Negative 2 times 4 is going to be y is equal to negative 8 plus 5. Y is going to be negative 3. Remember, a coordinate point is x comma y, so my answer will be 4, negative 3. Okay, a little bit of new, a little bit of old. Everything is being mixed together, and essentially the idea is that we should be practicing what we've learned and slowly integrate it with our new lessons. I hope this helped. This has been it for today. Ciao.